Hello, friends. Welcome to Podcast Vault. The purpose of this channel is to give you a better listening experience through audiobooks and informative audio content. Whether you're short on time to read or on the go, knowledge is now just a click away. Make sure to watch this video till the end to find out what we have in store for you. If you like our effort, don't forget to like, share, and subscribe to the channel. Also, comment below and let us know what kind of content you'd like to hear more of. Thank you from the bottom of our hearts for your support. At Podcast Vault, every word is for you.
Welcome back to the deep dive. We've got a really interesting topic today, one you actually brought to us. You sent over this great stack of sources, articles, research papers, even a YouTube transcript, all looking at India's own navigation system, Navic.
Right, and how it compares to, well, the system most of us use every day, GPS.
Exactly. So our mission today is to unpack all this material you sent. We want to figure out what Navic actually is, why India went down the road of building its own system.
Which is a fascinating story in itself.
Definitely. And then, get into the technical side. How does it stack up against GPS based on these sources? What does it all mean for navigation, security, technology, all that stuff?
And there are some surprising origins and some key technical differences that really stand out in the material.
Okay, let's jump right in then. Where does the Navic story really begin?
Well, to really get why Navic exists, you kind of have to rewind to the late 90s, specifically 1999 and the Kargil conflict.
Right, the war between India and Pakistan fought in those really high, difficult mountains.
Exactly. And during that war, the Indian military found itself needing really precise location data, for planning, for operations, just knowing where things were in that terrain.
Super critical in that kind of environment, I imagine.
Absolutely vital. They needed reliable positioning, tracking their own forces, targeting the usual things.
And back then, the go-to system for that kind of thing was the U.S.-controlled GPS, wasn't it?
That's it. GPS was the standard. So according to these sources, India actually made a direct request to the U.S. They asked for access to, let's say, enhanced GPS data just for that specific Kargil region.
Makes sense. And the U.S. response was?
They said no.
Wow, just
No.
during an active conflict.
That's what the sources indicate. A denial of access to that crucial data. And that was the pivotal moment.
I can only imagine. Needing something vital for a military operation and the provider of the global standard just denies it, that must have been a huge shock.
It was definitely a wake-up call. You see that emphasized again and again in the sources you sent. The big takeaway for India was crystal clear. Relying on a system controlled entirely by another country, that created a massive vulnerability.
Especially when national security is on the line.
Right. If access could be denied during a conflict, or even just during political tensions, that's an unacceptable risk.
So Kargil wasn't just a technical issue, it was the reason they decided to build their own system.
Pretty much, yeah. That denial created the absolute imperative. The goal became clear: develop an independent, homegrown system. Ensure you always have access to PNT positioning, navigation, timing for military and civilian use no matter what, free from foreign control.
That context really frames the whole project, doesn't it? So how long did it take from that realization after Kargil to actually getting Navic running?
Well, the idea sparked right after Kargil. The project itself got the green light, formally approved, in 2006. First satellite went up in 2013, and they declared it operational around 2016.
So roughly a decade from approval to operation. Pretty quick for building a satellite constellation.
Given the complexity, yeah, it moved relatively fast.
Okay, so that covers the why, a really compelling reason. Now, let's get into the what. What is Navic, fundamentally?
So Navic stands for Navigation with Indian Constellation. The official technical name is IRNSS, Indian Regional Navigation Satellite System.
And its basic job, like GPS, is providing those PNT services, positioning, navigation, timing.
Exactly. Accurate PNT. And just like GPS, it uses a set of satellites sending out signals and a network of ground stations keeping everything monitored and controlled 24/7.
How's its constellation set up? GPS has, over 30 satellites for global reach? Navic is smaller, right?
Yeah, it's designed differently because its focus is regional. The plan was for a minimum of 7 operational satellites. What's really distinct is the orbit design. It's a hybrid mix.
Hybrid? How so?
You've got 3 satellites in geostationary orbit, or GEO. They're way up at about 36,000 kilometers and basically stay parked over the same spot above India.
So they look fixed in the sky from down here.
Right. And then there are 4 satellites in inclined geosynchronous orbits, GSO. They have a 29-degree inclination, so they trace this sort of figure-8 pattern in the sky, but they still return to the same relative position each day.
Oh, okay. And that combination is optimized for covering India.
Precisely. It's designed to give strong coverage over the Indian landmass and the immediate surrounding region.
And the sources mention the current status. I think you said not all launch satellites are fully working.
Yeah, that's right. The sources, as of mid-2025, indicate that out of 11 satellites launched in total for the system, 5 are currently fully operational. That points to one of the challenges the system has faced, which we should definitely talk more about later.
Okay, duly noted. And the coverage area, as the name suggests, it's regional, not global.
Correct. It covers India and then a zone extending about 1,500 kilometers beyond its borders.
Got it. And the price tag for building this?
The sources put the total investment around 2,250 crores, which translates to roughly 270 million US dollars. A pretty significant national investment.
Okay. Now, before we really pit Navic against GPS technically, one of the sources you sent briefly mentioned the origin of Google Maps. Why bring that up?
Well, it's useful context, mainly when we get to the discussion around things like privacy and the business models. It helps to remember that Google Maps, the app most people think of for navigation.
Yeah, the one on my phone.
Right. It didn't start as a satellite system. It actually began back in 2003 as a mapping technology company, in Australia, actually, called Where To Technologies.
So software focused on displaying maps, not the satellites providing the location.
Exactly. Google bought Where To Technologies in 2004. They then developed it into the web app we know, launched in 2005. And while it does lots of clever things, its core function of pinpointing your location primarily relies on pulling data from satellite systems, mostly the U.S. GPS.
Okay, that's a helpful distinction. Navic is the underlying satellite infrastructure, government-controlled, born from that strategic need. Google Maps is a commercial app that uses satellite data, mainly GPS, to offer map services.
Right. And understanding the difference government infrastructure versus commercial application becomes important, especially, like I said, when we look at data privacy later on.
Makes sense. All right, let's get into that technical showdown then, based on what the sources tell us. Navic versus GPS.
Okay, yeah. We can break it down using the key things mentioned: coverage, accuracy, compatibility, and privacy.
Coverage seems pretty straightforward. GPS has global reach with its, 31 operational satellites. Navic is regional India plus that 1,500-kilometer zone.
Correct. GPS wins on sheer global coverage, no question. But accuracy. Now, that's where things get interesting, especially within Navic's service area, according to these sources.
Oh, how so? That YouTube transcript you sent made a pretty strong claim, didn't it?
It did, yeah. It claimed Navic gets you down to about 5 meters accuracy with its setup, while suggesting GPS, even with more satellites, is maybe more like 20-25 meters accurate in the region, sometimes even off by more.
That's quite a difference. Do the other sources back that up?
The numbers vary slightly, which isn't too surprising. One source says Navic civilian signals achieve 5-10 meters within India, whereas GPS is typically around 20 meters in that same region. Another one puts GPS at 10-15 meters globally, perhaps, but Navic under 10 meters within India, though maybe worse than 20 meters out towards its coverage edge.
So, okay, the exact meters might differ depending on maybe the receiver or testing conditions, but the general drift seems consistent. Navic is potentially more accurate than GPS within India.
That seems to be the consistent claim across the sources, yes. Better regional accuracy.
Why would that be? What's the tech behind that potential advantage?
The sources point to 2 main technical reasons. First up is its use of dual-frequency signals. Navic broadcasts on 2 different frequencies, the L5 band and the S band.
Okay, 2 frequencies. Why is that better than 1?
Well, think about the Earth's atmosphere, specifically a layer called the ionosphere. It's full of charged particles. When satellite signals pass through it, they get slightly slowed down or bent, kind of like light bending through water.
Right, causes delays.
Exactly. And since navigation relies on super precise timing of those signals, these atmospheric delays mess up the calculation and introduce errors in your position. But if your receiver gets signals on 2 different frequencies, like Nevis, Velive, and S-bands, it can compare how much each frequency was delayed. Because the delay effect is frequency dependent, the receiver can figure out how much error was caused by the atmosphere and then correct for it.
Sort of like having a built-in error checker for atmospheric conditions.
That's a good way to put it. Now, GPS also uses multiple frequencies, like L1, L2, L5, but the sources really highlight Navic using dual frequencies for its civilian service as a key advantage, especially for the atmospheric conditions often found over India and tropical areas.
Got it. Dual frequencies for better atmospheric correction. What was the second reason?
The second one goes back to those orbits we talked about, the mix of GEO and GSO satellites. Because of where they are positioned, The satellites tend to appear higher in the sky when viewed from India.
Higher elevation angles, you mean, coming down more vertically.
Exactly. Signals coming from higher up are less likely to get blocked by buildings in cities or dense forests or mountains, all things you find plenty of in India.
Makes sense. Fewer obstacles, cleaner signal path.
Right, so that improves signal availability and reliability, especially in what you might call challenging reception environments. And better signal means potentially better accuracy.
Okay, that makes a lot of sense. The sources also mention timing accuracy.
Yes, crucial for navigation. You need incredibly precise time. The sources state Navic aims for better than 40 nanoseconds accuracy, and one even mentioned a figure as low as 12 nanoseconds. GPS is typically cited in the 10-30 nanosecond range. So Navic is built for very, very precise timing in its region.
All right, so Navic has these potential regional advantages, accuracy, timing thanks to dual frequencies and satellite placement. But what about just using it? Can my phone pick it up right now?
Well, that's where GPS currently holds a massive advantage, just in terms of sheer market penetration. To actually use Navic signals, your device needs a specific Navic-compatible chipset.
So it needs the right hardware inside.
Correct. And while ISRO, the Indian Space Agency, has worked with chip makers like Qualcomm, getting those chipsets into a wide range of smartphones and other devices, well, that's been a slower process. It's been a bit of a challenge.
But isn't that changing? I thought one source mentioned a government push.
Yes, absolutely. That's a key development highlighted. The Indian government has mandated that all new 5G phones sold in India must support Navic C starting from January 2025.
Okay, so a big move to drive adoption within India. But for now, outside of maybe newer phones in India, GPS is pretty much the default everywhere else.
Pretty much, yeah, globally integrated. Which leads us nicely into the next comparison points the sources bring up, privacy.
Privacy. How does that differ between Navics and, say, using Google Maps, which relies on GPS?
Well, one source directly contrasts the two models. It points out that an application like Google Maps uses GPS data, sure, but it's provided by Google, a private company. And according to this source, Google uses your travel data, your location history, and other info.
For targeted ads and things like that?
That's the claim made in the source, yeah. Selling that data to third parties is part of the business model. So the implication is the free map service isn't entirely free when you factor in your data privacy.
Okay, I see the point. How does Navic compare then?
In contrast, Navic is operated by ISRO, which is India's government space agency. The source emphasizes that ISRO, being a government entity, doesn't have that same commercial motivation to, collect and sell user location data to advertisers.
So the argument is that with Navic, your location data stays within a national non-commercial system, offering potentially better privacy.
That's how it's framed in that source, yes. A significant potential advantage for personal data security, particularly for users within India.
Interesting point. Okay, so we've talked about using Navic C for basic navigation, like on a phone map. What other kinds of applications do the sources mention? It's not just for driving directions, right?
Oh, definitely not.
Well,
the sources really paint Navic as foundational technology. The applications cover a really wide spectrum.
like what?
Well, for defense, obviously secure, encrypted navigation is huge, less vulnerable to jamming or spoofing compared to relying solely on foreign systems. Border surveillance is another key military use.
Makes sense. What about civilian uses?
Lots there, too. Things like tracking public transport, coordinating emergency services during disasters, think floods, earthquakes, precision agriculture, where farmers need exact positioning for planting or fertilizing, maritime navigation for ships in Indian waters.
So really embedded in critical services.
Yeah. And then looking ahead, the sources mention emerging applications, too. Things like autonomous vehicles, which need hyper-precise location, smart city infrastructure, managing networks of connected devices, the Internet of Things, or IoT, even financial transactions, using the precise timing for timestamping, and synchronizing critical infrastructure like power grids.
Wow. Okay, so it really underpins a lot more than you might first think. It's about enabling a whole digital society.
Absolutely. And that really underscores the strategic importance we talked about earlier. Navic is about India achieving self-reliance, independence, in a technology that's becoming fundamental to, well, everything.
Enhancing security, economic sovereignty, building tech capability, all by reducing that reliance on foreign systems.
Exactly.
It's clear why it's such a priority. But, running a satellite system isn't easy. What are the challenges Navic is facing, according to the sources, and what's next for it?
Yet the sources don't shy away from the challenges. One big one comes up is satellite reliability. Specifically, there have been issues with the atomic clocks on some of the earlier satellites failing.
Atomic clocks. Right, those are needed for the super precise timing.
Precisely. Navigation is all about timing signals down to the nanosecond. The atomic clocks on the satellites are the time standard. If a clock fails or gets unstable, the signals from that satellite just aren't reliable enough for accurate positioning. It basically takes that satellite out of useful commission.
And the fact that, as you mentioned, only 5 out of 11 launched are fully operational now, that points directly to this clock issue.
It strongly suggests those reliability issues have been significant, yes.
Yeah.
It requires replacements and impacts confidence.
Sounds like a major technical hurdle they need to consistently overcome.
It is. And then there's the adoption challenge we touched on. Getting manufacturers to widely include Navic chipsets, even with the 5G mandate, it takes time for older devices to phase out. And just consumer awareness. People are used to GPS.
Plus competing with the whole GPS ecosystem, which is everywhere.
Right. The dominance of GPS is huge. You also need applications specifically designed to leverage Navicoi's strength and robust tools and support for developers to build those apps. So market penetration is definitely an ongoing uphill battle.
So what's the plan? How are they addressing these things? Is there like a Navic 2.0 in the works?
Yes. The sources mention future plans, often talked about as Navic 2.0 initiatives. They're tackling these issues directly. There are plans to launch more satellites, including a new series called NVS Navigation Satellite Second Generation. These are designed with improved, more reliable atomic clock technology.
Directly addressing the clock problem.
Exactly. And another big upgrade planned is adding the L1 frequency band to Navic signals.
L1. Isn't that the main frequency most civilian GPS devices use?
It is. Adding L1 would make Navi's signals compatible with a much wider range of existing and future receivers globally. That's a huge step for interoperability and easier adoption. There's also talk about integrating Navis more deeply into India's national digital infrastructure, and maybe even exploring ways to expand its reach or partner with other countries down the line.
So it's not just about fixing the initial problems, but really evolving the system for broader use and maybe even looking beyond the region eventually.
That seems to be the direction. And the sources also touch on the potential economic upsides. Saving money on defense by being self-reliant, generating revenue as civilian applications grow, potentially exporting the technology, and creating high-tech jobs in India's space sector.
This has been really illuminating. It's a system, like you said, born out of a critical need, built with some clever technical ideas for its region, but also facing those tough, real-world challenges of technology and competition.
Yeah, that sums it up well. The key takeaways from the sources really are: Navic started because of that Kargil wake-up call about strategic vulnerability. It does offer potential technical wins, like better regional accuracy in India due to those dual frequencies and high-angle satellites. And it presents, according to one source at least, a different model regarding user privacy compared to commercial services built on GPS.
But on the flip side, it has struggled with satellite reliability, the clock issue being a prime example, and it faces that steep climb to get widespread adoption against the giant that is GPS.
Right. Ultimately, Navic is India's big bet on strategic autonomy in space. It's about security, sovereignty, and building national capability in a critical tech area with aspirations for the future.
Okay, so here's something for you, our listener, to chew on. As these navigation systems get woven deeper and deeper into everything, not just your phone map, but think critical infrastructure, emergency response, maybe even self-driving cars soon, how does that choice between relying on a global system, mostly run by one country, versus developing and using a regional homegrown system? How does that choice affect things? Not just your convenience getting from A to B, but bigger stuff like national security, economic opportunities, and yeah, even how private your own location data really is.
It's a complex mix of tech, policy, economics, and trust. And it's only going to become a more relevant question, I think.
Definitely something worth thinking about as this technology keeps evolving all around us.